Good morning to one and all. Today we are going to see the concept of polymorphism in Java. We have already seen the method overloading and method overriding concept in Java, which is also the concept of polymorphism. Polymorphism means many forms, and it occurs when we have many classes that are related to each other by inheritance. Inheritance, as you know, it lets us inherit attributes and methods from another class. Polymorphism uses those methods to perform different tasks. This allows us to perform a single action in different ways. For example, there is a class superclass that is parent class animal and that has a method called animal sound. Subclasses or child classes of the animal can be pigs, cats, dogs, birds, and they have the same method animal sound, which will be different for each of the subclasses. Like for pig, cat, animal sounds will be different. So this is the concept of polymorphism, one method and many forms. There are two types of polymorphism, compile time and runtime. We can perform polymorphism in Java by method overloading and method overriding, which are already studied in the last video. If you overload a static method in Java, it is an example of compile time polymorphism. And here we will focus on all the concepts of polymorphism, static, runtime, and also operator overloading. Compile time polymorphism. It is also known as static polymorphism. This type of polymorphism is achieved by function overloading and operator overloading. What is function or method overloading? When there are multiple functions with same name but different parameters, then these functions are said to be overloaded. I repeat, multiple functions with same name. Name should be same. It can perform different operations. We will see the example in the next slide. Functions can be overloaded by change in the number of arguments or change in the type of argument. You can perform in both the ways. We will see the example where we are changing the type of argument. Now here is my class multiply function. Here is my function multiply, in which I have passed two parameters of type integer, which we will return the multiplication of two numbers. And then here is my another method of multiply, which is accepting double here, and here is the integer input. So here it will return the output of type double, that is, it will return the decimal value. Here the name of both the functions are same, only arguments are different. So this is multiple functions with same name. Now there is a class main class in which there is a main function. Here I will perform the operations multiply 2, 4. So here integer is my input variable of actual parameters, and here is the formal parameters. It will return the value of 2 into 4, that is 8. And second statement, print statement, it will multiply the double value, that is 5.5 and 6.3, which will return the value 34.65. So this is the example of static polymorphism, that is compile time polymorphism, which is of type change in the type of arguments. Now next we will see what is runtime polymorphism. It is also known as dynamic method dispatch. It is a process in which a call to an overridden method is resolved at runtime rather than compile time. In this process, an overridden method is also called to the reference variable of a superclass. The determination of the method to be called is based on the object being referred to by the reference variable. Here we will first understand what is upcasting before runtime polymorphism. Upcasting means if the reference variable of a parent class refers to the object of child class. I repeat, if the reference variable of a parent class refers to the object of the type class, it is known as upcasting. We will see the example here. This is class A, another class B, which inherits the property of class A. So here, reference variable of a parent class, it refers refers to the object of the child class. Here is the A variable which refers to the object of child class. Another example here, for upcasting, you can use also the reference variable of a class type or a interface type. You can also use interface type here. For example, I have used interface I, then is my class A, then B inherits the property of class A which implements I. So according to these sentences, this statement, you can say that B is a type of A. It is a relationship which refers to A. B also refers to I, as well as it refers to the object. This is a type of upcasting in polymorphism. Now we will see the example of runtime polymorphism. Here I have two classes, bike and splendor. Here splendor class extends the property of bike class. Another one, there are same method in both the classes. So here we have overridden the method run. Now here is my main class, main function, and in main function I have created the property of upcasting, that is the parent class. Run method, we are calling the run method by reference variable of a parent class. B is the reference variable of the parent class bike. Since it refers to the subclass object and subclass method override the parent class method, the subclass method is invoked at runtime. I repeat. Now here B refers to the subclass object. B is the object of subclass. Splendor is the subclass. And subclass method overrides the parent class. This is also run method. This is also run method. It overrides the parent class. And so when we are calling this function, it will call the function which is in the subclass, that is splendor class, and so we will get the output running safely with 60 km. Got the example what is upcasting? Next we will see Java runtime polymorphism with data member. Here there are two classes again, bike and Honda. Here we have used same variable with different value, so 90 and 150. Here a method is overridden, not the data member in Java. In the previous example we have seen the overridden method run, but here data members cannot be overridden. So runtime polymorphism cannot be achieved by data members. In this example, both the classes have same data member speed limit, and we are accessing the data member by reference variable of the parent class, which refers to the subclass object. Since we are accessing the data member which is not overridden, as data members cannot be overridden, so here we will get the output as 90, that is main class object. In the previous example we are getting the statement within the subclass, but here data members cannot be overridden, so we will get the output of main, that is parent class. So here in output we will get 90 as a value. Next concept is operator overloading. Java also provides options to overload the operators, but here only one operator in Java can be overloaded, that is plus. We can make the operator for string class to concatenate two strings. So using concatenation, if you want to perform concatenation, you can use the operator plus. Also we can perform addition of two integer values. So here a single operator, when placed between two integer operands, it will add them, and if it is placed between two strings, it will concatenate it. So here plus operator can be overloaded to perform two operations, to add integers and to concatenate two strings. So we will see the example of operator overloading. Now here is my class name is operator overridden. Then is my two methods with same name. One is accessing different argument, that is string as an input variable, and another one is accepting integer as input variable. Now here it will perform the concatenation of two strings str1 and str2. In second method, it will perform addition of two variables a and b. Now here is my main class. Now in main I have my main function. Here I have created an object, as here there is only one class, only one object is created. Now here through first statement I am calling the operator function which is going to accept the input variable as integer. So 2 and 3, it will perform the addition and it will print sum equal to 5. Here is my output, first output statement. In the second statement, I am calling two strings str1 KBT, str2 COE. So using this, we can perform concatenation of two strings, which will be the result concatenated string S, that is KBTCOE. So here my operator is overloaded 2 times. So I think I have cleared with the ideas of all the three types of all the two types of polymorphism, static and dynamic, in which we have seen 3 examples of method overloading, then runtime polymorphism, and we have seen the example of how to overload the operator. So we have overloaded plus symbol in this example. Cleared with the concept? If you have any doubt, you can directly contact me. Thank you.